All right, hello once again, Jeff Scott of Rankin Technical College. And as part of the Rankin Technical College AWD, or Application and Website Development Program, and in particular the AWD 1111.NET Framework with Web Databases class, I've been doing a series of video presentations based on the textbook that will be used for this class for the fall 2019 semester. That textbook, as you can see on the screen, is ProASP.NET MVC 5, an A-Press text by Mr. Adam Freeman. And so far, out of the 27 chapters, I've done 1 through 12, had problems with Chapter 13, and have now finished 14, 15, and 16. So, I'm going to get into 17 right now on controllers and actions, and then you can see what's left. All right, as I mentioned previously, I'm going to try to kind of quicken the pace a little bit, and I'd like to do no more than 5 or at the most 6 lectures for each chapter, where each lecture is about 15 minutes in length. That may seem like I'm not giving it a lot of coverage. I'm doing the best I can. I'm not making excuses, believe me. But I'd like to get through the book because I've got work to be doing, other work that I have to be doing. So, Chapter 17, I'm on page 451. Every request that comes to an application is handled by a controller. The controller is free to handle the request any way it sees fit, as long as it doesn't stray into the areas of responsibility that belong to the model and the view, meaning controllers do not contain or store data, nor do they generate UIs or user interfaces. Back in Chapter 3, the author explained that the role of the controller is to encapsulate application logic, meaning controllers are responsible for processing the incoming requests, performing operations on data returned from the model or models, and selecting the view or views to render to the user. In this chapter, the author is going to show how controllers are implemented and the different ways that controllers can be used to receive and generate output. So as you can see right here, there's 26 pages in the chapter. Again, as has been the way I'm doing this, I'm not going over this. So you can just take a look at it, and it's up there. So, preparing the example project. So it says in here, we're going to prepare a new project called Controllers and Actions that will be empty. All right. And I'm not going to, again, worry about the unit tests. So I'm not even going to read that part. And I don't need to add that either. So I will create a new project. It will be an ASP.NET web application. It will be called Controllers and Actions. And I'm going to call the name of the solution Chapter 17. It will be empty, but it will contain the MVC folder structure. All right. So the author says once you've created it, okay. Once you've created it, go over to your properties, switch to web. You know the routine, we've done this before. Project, properties, go over to web, find where it says specific page, check that, but you don't have to fill in anything. We don't need this. All right. You have seen the use of controllers in almost all chapters thus far. Now it's time to step back and take a look behind the scenes. In the MVC framework, controller classes must implement iController. We already know this. All right. Every controller that we have created, and I don't think we have any in here. We don't. But they all have the iController. So they're all implementing, all right, the iController interface. Since that interface is defined in system.web.mvc, that's why we need that using statement. All right. It says this is a simple interface. All it says is that you must have a method in here that is called execute. And it's going to be invoked when a request is targeted at the controller class. It says here the MVC framework knows which controller class has been targeted in a request by reading a value of the controller property generated by the routing data. You can create controller classes by implementing iController. All right, so we could do that, but I don't know if there really is a reason to do that, is what the author is saying. All right, I created a new class file called basic controller in the controllers folder. And it'll have the content shown here on page 453. Again, you will notice as we get back to this in a second, right? Implements iController. All right, so you've seen that before. We'll continue to see it. So the execute method of the iController interface, as mentioned there, is passed to a system.web.routing.request context that provides information about the current request and the route that matched it. The request context class defines two properties as shown here. They are HTTP context. Notice it returns an HTTP context base object that describes the current request, and route data, which returns a route data object that describes the route that matched the request. All right. The HTTP context base provides access to a set of objects that describe the current request, known as context objects. Some of those properties that includes are shown here on the bottom of the page. Oops. They being route returns the route-based implementation that match the route. Route handler returns the iRoute handler that handle the route, and values, which is a collection of segment values indexed by name. All right, top of page 454. Class names that end with base. The MVC framework relies on the ASP.NET platform to process requests. All right. One problem is that the classes that the ASP.NET platform uses to provide information about requests are not well suited for unit testing. So far, the ASP.NET platform has provided context information about the current request and some key application services through an HTTP context object. The base class counterpart is HTTP context base, an instance of which is passed to the execute method. Now the author mentions here on the bottom of page 454, you can see it here, part of the problem when creating custom controllers is you don't have access to features like views. This means that you have to work at a lower level, and is the reason that the author writes his content directly to the client. All right. So if you run the application and navigate to basic index, you should see the output generated by the custom controller. Well, we did put it in, so let's try it. Let's do a file, save all. I think I did it. Save all. Run this. says we've got an error, but we're going to navigate over to /basic/index, and it's got controller action or basic action index. Good. All right. And the author mentions then on the top of the next page, implementing the iController interface allows you to create a class that the MVC framework recognizes as a controller and sends requests to without any limitation on how said request is processed and responded to. All right. Next, creating a controller by deriving from the controller class. As mentioned right here, system.web.mvc.controller is the class that provides the request handling support that most MVC developers are familiar with. It is a class we have been using for all examples in the previous chapter. The controller class provides, as mentioned here, 3 key features. All right. The first being action methods, where each action method is exposed on a different URL and is invoked with parameters as necessary, extracted from the incoming request. Action results, which can return an object describing the result of an action, which is then carried out on the user's behalf. And filters. With filters, you can encapsulate reusable behavior. All right. Unless you have a specific requirement in mind, the best way to create controllers is to derive from the controller class. And as you might hope, that is what Visual Studio does when it creates a new controller in response to the Add Scaffold menu item. Listing 17.3 shows a simple controller created this way called derived controller. All right. Well, what does that mean? That means we come in here, right mouse click, add controller, empty, add derived controller. Click add. And you can see we get the using statements that are shown here, including our important one, the using system.web.mvc. All right. And the author wants us to add a little bit of information to this. That being under the index method, we are to change it so that it looks like this, just hello from there. So what does that mean? Well, it means as of right now, we're using, and again, this is just done for demo purposes. What the author is doing right here is he is using the controller as both the controller and the view. All right. The controller class is also the link to the Razor view system. First, let's save and run this. I don't know if we have to put index in there or not. File, disable derived controller, index. I don't know why that wouldn't work. It's in my controllers folder. But as you can see, it's not working. I don't think you'd have to put home first. That wouldn't make any sense to put home in there, but it does not like what I'm putting in here. It is the same thing that they are showing. Oh, it's just, that's, Jeff. You don't put the word controller in there. I'm sorry. Derived. Index. All right. So right now, it does not have a view, which we're going to put in just a minute. All right, so we would actually leave that out. Yeah. We'd stop the run. I think we'd do that. All right. And we, well, it's got it here. Return view, my view. All right. But what we are going to do is right mouse click on here, add a view. It'll be called index. In fact, the way they show it on here is to come into views, derived, right mouse click, add, new item, go to MVC, MVC 5, view page razor, call this my view. Click OK or hit enter, and then we're going to change the what's in there to this. All right, let's run it again. And you saw when we did it previously, and we went to slash derived slash index, we got an error, but now there you go. So the job of a derivation of the controller class is to implement action methods, obtain whatever input is needed to process a request, and generate a suitable response. That's pretty much what this chapter is about. All right, receiving request data. Controllers frequently need to access data from the incoming request. Examples, query string values, form values, parameters parsed from the URL. There are three main ways to access this data. First, extract it from a set of context objects. Second, have the data passed as parameters to the action method. Third, explicitly invoke the framework's model binding feature. I think the author is going to look at all three of these approaches. All right, starting now. It says, here I look at the approaches for getting input for your action methods, focusing on context objects and action method parameters. In Chapter 24, the last one, the model binding, will be discussed in more depth. All right. As the author mentions here, when you create a controller by deriving from a controller base class, you get access to a set of convenience properties to access information about the request, including request, response, route data, HTTP context, and server. Each of these, as mentioned, provides information about a different aspect of the request. The author calls these convenience properties because they each retrieve different types of data from the request control context instance. Some of the main properties are shown on the screen here in figure or table 17.4. Underneath that, the author says these individual properties referred to here provide context objects. He's not going to go into them in detail in the book. However, he does mention on the bottom of the page they provide access to some useful information and features and are worth explaining. An action method can use any of these context objects to get information about a request. Listing 17.5 demonstrates the form of a hypothetical action method. Now notice, since it's hypothetical, I'm not going to put it in any place. All right? And the author mentions smack dab in the middle there of page 458. It's kind of where my cursor is playing around here. You can explore the vast range of available request context information using IntelliSense. All right. All right. Using action method parameters. As you have seen in previous chapters, action methods can take parameters. This is a neater way to receive incoming data rather than extracting it manually from context objects. It also makes your action methods easier to read. So for example, suppose we have this. We can rewrite it so that rather than putting it in here, we can put it in there as being parameters that are passed in. Not only is this easier to read, but it can cut down on the time used for unit testing. It is worth noting that action methods aren't allowed to have out or ref parameters. Remember, an out parameter, if you pass in an out parameter to a C# method, that means the value does not have the parameter does not have a value when it's passed in, but will have one by the time it's passed back. And a ref means that you can have as many ref parameters as you want. That means that you are passing the address so you can make changes in the method. And as the author says there, it wouldn't make any sense if they did, and the MVC framework would simply throw an exception. The framework will provide values for action method parameters by checking the context objects and properties automatically, including the request.query string, request.form, and request.values. All right? So, understanding how parameter objects are instantiated. The base controller class obtains values. In fact, let's check my time. Okay, I'm already over. That's it for this particular presentation.